Namaste everyone, welcome back. In this video, we will solve one of the most frequently asked interview questions on LeetCode, longest substring without repeating characters. This problem introduces one of the most important review techniques called the sliding window. By the end of this video, you will understand why the brute force solution is inefficient, how to think about the optimal approach, and how to write the solution in Python from scratch. Let's begin. We are given a string. Our task is to find the length of the longest substring that contains no repeated characters. Notice the word substring. A substring means all characters must be continuous. For example, if the input is ABC, ABC, double B, the answer is 3 because ABC is the longest substring without repeating characters. Even though A contains 4 characters, it repeats A, so it is not valid. So let us look at another example. All B. So here answer will be 1 because if we take the length greater than 1, then it will have repeating characters. One more example is this PWWKEW. So here output is 3, this one is valid, and this one is valid. So both are length 3. Notice that PWKE is not a substring. Those characters are not continuous, so it does not count. Now let's go with the first thought, the brute force technique. A straightforward idea is to generate every possible substring. For each substring, check whether every character is unique. Keep updating the maximum length. So will this work? Yes. Is it efficient? Not at all. There are around n square substring. Checking uniqueness can take up to n time. Overall complexity becomes O n cube. So the idea is generate every possible substring. This is the idea. And then for each string, check whether every character is unique or not. And keep updating the maximum length. So its time complexity will be n cube. Now let us look at the constraints. So constraint is that the length can go to 50,000. So this will become very slow. We need something better. Suppose we already have a valid substring. For example, ABC. Now we try adding another character. If the next character is not already inside the substring, great. We simply extend it. But what if the next character already exists? For example, ABCA. Now we have two A characters. Instead of throwing everything away and starting again, why not remove characters from the left side until the duplicate disappears? This is exactly where the sliding window technique comes in. So optimal approach is sliding window. So we maintain a window using two pointers. The left pointer marks the beginning of the substring. So what exactly is this? The left pointer marks the beginning of the current substring, and the right pointer keeps expanding on substring. Inside this window, every character must remain unique. This is the condition. Whenever the right character creates a duplicate, we keep moving the left pointer forward, removing the character from our window until the duplicate is gone. Then we continue expanding again. So we check this. If right character contains a duplicate, then we start shrinking the window from the left until the duplicate disappears. This way, every character enters the window once and leaves the window at most once. That gives us a linear time solution. Now, how do we quickly know whether a character already exists inside the window? So we will use a hash set. So a set gives us O1 average time for insertion, remove, and lookup. Perfect for this problem also because our strings are limited. We have only English letters, digits, symbols, and spaces. So that is not even 100. At most 200, not more than that. So we can safely use a hash set. So the point is that we can easily look up for a character in order one time. Now let us write down the complete algorithm. So create an empty set, left equals 0, max length equals 0. Now iterate through the string using the right pointer. So for right, uh, for right in range length of the string. For every character, check whether it already exists inside the set. If if str right exists in set, then keep removing. So I will write while. So keep removing the left character from the set and move the left pointer forward. Left plus equals 1. So we need to do this until the duplicate disappears. Now once it is done, now insert the current character into the set. So once the while loop ends, then we insert add str right insert. Finally, we calculate the current window size. So update max length. Uh, so current window size is equal to right minus left plus 1. Right minus left plus 1. That you can check with an example. Then we update the maximum answer and continue until the string ends. And finally return the maximum length. So this is simple and efficient. Now let us write the Python code. Let us go step by step. Scene equals set, left equals 0, and answer equals 0. Now we run the loop. Or write in range len of the string. Then we run another loop, a while loop inside. If s right, the current element is in the set, then we keep on removing the leftmost element and increasing our left pointer. Finally, we add the current element into the set and update our answer. This is the size of the current sliding window. Finally, we return the answer. Now let us dry run this to understand better. So this is our string. Initially left equals 0. And set is empty. And max length, that is answer, equals 0. Now right points to A. So right equals 0. It is not present at right equals 0. S right equals A. Now it is not present in the set scene. So it will be added to the scene set. So scene will become this. And answer will be max of left minus right plus 1. So answer will become 1. Now at right equals 1. S right equals B. Now it is not in the set. So scene will become A and B. And answer will become 2. That is max of answer comma right minus left. So right is 1 minus 0 plus 1. That is equals to. Now let's at right equals 2. So S right will become C. Scene will become, because it is not in the set, so this will again be added, and C. And answer will become 3. Now at right equals 3. S right will become A. Now it is inside the scene set. So the left will increase. So left will become 0 plus 1 equals 1. Now, and scene will become scene dot remove as left. So first scene will be removed, then left will be increased. So scene will become this, just B and C, and left will become 1. Then we'll again check, now A is not there in the set, so scene will become B, C, and A. I am writing as per the insertion order, but inside the set, order is not maintained. Then answer will remain as 3. Then we can do for at right equals 4, S right equals B. Then S right equals B, and but it is inside the scene set. So scene will become C and A because B has been removed. And left will become 2. Next time it is not in the scene set, so scene will again become CAB, means ABC, and answer will remain as 3 because answer is max of answer comma right minus left plus 1. So that is equals 3. 4 minus 2 plus 1 is 3, and answer is also 3. It remains as 3. Now add right equals 5. So this is 1, 2, 3, 4, 5, 6. So S5 is 6. S5 is C. And C is inside the scene set. So it will get removed. So it will become A comma B, A and B. Then it will again check. Now it is our left will also increase. So left will become 3 this time. Now next time it is not there. So scene will again become ABC. And our answer will remain as 3. Now at right equals 6. So S right will be B. Then we'll check scene, and then it will remove the B. So similarly, it will continue, and the answer will remain as 3 because it always takes a max. So this you can complete on your own. This dry run helps us to understand the code very deep. So we must do dry run before running the actual code. Now let us run the code, and now let us submit it. So all the test cases pass, and it is super fast. We can analyze the time complexity. It is ON because each of the element maximum enter once and exit once. So it is processed 2 times at max. So it is of the order n, 2 times n. So that is on. Space is constant because we are not using any other array. Um, Actually, we are using a hash set. So we need to check for that. So it is min of n comma character set. So character set is usually lesser than n. So it is equal to O of character set. Because we just need to keep the distinct items in the set. So we need to maintain that. So it is practically O1 only, but it is better to write O as character set. So let's say if our S contains not just English letter, but some specific numbers or some symbols that can have a different, for example, K different symbols are there. So it will be of order K. This is the optimal solution for this problem. Now let us discuss some common mistakes. So first mistake is forgetting to remove characters while duplicate exists. So an if statement is not enough, you must use a while loop. Second mistake is completing the window size incorrectly. So always remember it is right minus left plus 1. Third is confusing substring with subsequence. A substring must always be continuous. Finally, updating the answer before removing duplicates. Always ensure your window is valid first, then update the maximum length. So let us quickly summarize. We need the longest substring with all unique characters. Brute force is too slow. Sliding window lets us expand and string efficiently. A hash set helps detect duplicates instantly. Every character is processed at most twice. Final time complexity is ON. This sliding window pattern appears in dozens of coding interviews. So mastering it will help you solve many other problems as well. If this explanation helped you, don't forget to like the video and subscribe for more Python DSA and AI interview content. Thank you for watching, and I will see you in the next video.